Today is Tuesday, October 29th, and we are going to be visiting complex numbers. And without realizing it, on Friday when you grabbed quadratic equations and you were asked how many real roots did a function like this have, you would say 0 real roots and no x-intercepts. And you didn't even realize it, but there was 2 complex numbers that existed here. When do complex numbers exist? How do we get answers? Well, let's just start with stuff that you do know. If I asked you to evaluate the square root of 36, and then I asked you to solve the equation x squared equals 36. On your own, you have 20 seconds to evaluate this expression and solve this equation. Go. When you evaluate something, you simplify it. What is the square root of 36? The answer is simply 6. When you solve, you're trying to find the answer to an unknown variable in this case. So to solve for the unknown variable x, I want to isolate it. I want to remove the square. Opposite of squaring something is the square root. This also tells us we're going to have 2 answers, so I put a plus and minus. Now, I already know the square root of 36 is 6. I bring that down, and in front is a plus or minus sign. Okay, let's move on to some very simple things that you know. Again, if I gave you 2x squared plus 3 equals, and let's go with 43. You learned how to do this freshman year, and it's just about simplifying our final answers. So first I'm going to subtract 3 to both sides as I do PEMDAS backwards to solve. Then I divide by 2. And now again, I'm solving for an unknown variable. And to get rid of the square, I'm going to square root both sides. This tells me I have 2 answers, and this cannot be my final answer. Why is that? With a square root, I need to consider perfect squares, 1, 4, 9, 16, 25. What is the largest number, if any, that divides into 20? The answer is 4, and 4 times 5. So x equals plus or minus 2 square roots of 5. These are the 2 answers that make this equation true. Okay, we're going to go back to complex. Complex has 2 parts to it. There's the real part, which we refer to as A, and the imaginary part, which we refer to as the B. How do you know which is which? So an answer like 3 plus 2i. 3 is the real portion. It contains no I. This is the imaginary portion, and it does have this cursive looking I with it. We're going to now see those within equations in which we solve. Let's start with a very simple one. X squared equals negative 49. First step would be to square root both sides if we were asked to solve this equation. Again, these cancel out here, and I bring down the x knowing that there are 2 answers, but wait, I can't take the square root of a negative number. So now what you're learning, this is brand new today, is this is going to sneak outside, and instead of being a negative on the outside, it becomes an I. You can take the square root of 49. X equals square root of 49, which is 7. I still have 2 answers. This is not wrong, but it's kind of like starting a sentence without punctualizing the first letter. So instead, we like to put the 7 behind the plus or minus, so it's 7i. And this would be my final answer. Okay, next one. Let's go with negative 4x squared minus 6 equals 74. Okay, so I'm asked to solve. I add 6 to both sides, doing PEMDAS backwards. PEMDAS backwards, I divide by 4. To get rid of the square, I square root, and remember I'm going to have 2 answers, but I cannot take the square root of a negative number, so it sneaks out front and becomes an I. If this would be your final answer, it would be wrong. What perfect square divides nicely into 20? 4 does. We want to choose the largest one, so it's going to be square root of 4 times the square root of 5. X equals plus or minus. The square root of 4 is 2. Then I'm going to put the I, and I'm going to put the radical last. First step would be to subtract 5, doing PEMDAS backwards. PEMDAS backwards would then be next to divide by 2. Here's where it starts to get a little confusing. To get rid of the square, I'm going to square root both sides. Remember, I'm going to have 2 answers, but I can't square root of negative. So this negative sneaks out front, becoming an I. Now, if 32 could not be broken down, sure, this would be the final answer. But I can break 32 down. A lot of students get confused on what number do I actually divide into. You want to choose the largest number. So 32 is right here. These are a list of perfect squares. I'm working with the square root, perfect squares. The first number, working backwards, that divides into 32 is 16. Square root of 16 times square root of 2. So square root of 16 is 4, plus or minus 4i square root of 2. In this problem, I'm going to start doing PEMDAS backwards. Different sign subtract, keep the sign of the larger number. Then divide by the negative 5. 2 negatives make a positive. How many groups of 5 are in 50? Which would be 10. Take the square root on both sides. What you have to remember with 10 is that we have a perfect square here. So 9, 4, and 1. What's the first perfect square that divides nicely into 10? There's only one, and it's 1. Does 1 break it down any further? So that tells us that my final answer cannot be broken down like the other ones. This is my final answer. We are going to move on to the next learning objective. Can I go have a red cup or green cup based on your confidence with this? Understanding patterns of I. We're going to understand it, we're going to get some answers, and then we're going to use the calculator to justify our answers and ensure they're correct. What you need to memorize is that I squared equals negative 1. So when I see I to the third, that means I times an additional I. And I know that this is negative 1, so it's really like negative 1 times I. Negative 1i. And I to the fourth is I times I, and I times I, and I know I squared is negative 1. So negative 1 times negative 1 is a positive 1. I to the fifth, the last one we'll go over, is I squared, and I. 5 of them. 1, 2, 3, 4, 5. I'm writing them in groups of 2 because I know a group of 2 i's is negative 1. It helps me to simplify this. Negative 1 times negative 1 times I. Negative 1 times negative 1 is just a positive 1, but what else is there? So, if you're like, I don't really get this. When we talk about patterns, the first number in the pattern is a negative 1. The second number in our pattern is a negative 1i. The third number is a positive 1, and the fourth number is a positive 1i, and then it cycles back again. Okay? First, when we do counting on our fingers in just a second, this is going to be first, second, third, and fourth. Okay? First, second, third, and fourth. Okay. So we're going to start right now, and we're going to evaluate, and I'm going to show you the really long way to do it, and then how we can count on our fingers. If I said to you I to the 11th, watch how long this is. Do not write this down. 11 i's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What do we know about 2i's? What does 2i's equal? So -1 times -1 times -1 times -1 times -1. 1, 2, 3, 4, 5. An odd number of negatives makes a final answer that's negative. 1 times itself 5 times is 1, and don't forget the negative. Sorry, don't forget the I. That seems like a lot of work to me. So now you're going to count on your fingers. Take one hand, please. We're going to count to 11. When we start every problem, after you put your thumb down, do not bring your thumb back up. So it looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's the second number in the pattern. The second number in the pattern is -1i. Done. And I don't have to do any of this work. Okay, watch the next one. Let me do it the long way on paper. You do not have to do it the long way. I'm going to do it way up here. Let's go I to the 8th. There's 2, 4, 6, 8. I know two i's make a -1. What is -1 times itself 4 times? Well, an even number of negatives gives you a positive, and 1 times itself 4 times is just +1. Okay? Let's see if this confirm that. Ready? Counting to 8. Do it with me, please. 1, 2, 3, 4, 5, 6, 7, 8. It's the what number in the pattern? What's the third number in the pattern? You don't have to do all this. This is just how it's created, okay? Here we go. Now I want you to figure out, and I'll give you a chance. Please write this down. Counting on your fingers and remembering this is the pattern. I want you with your partner to get those 3. I want you to evaluate those 3 expressions. Here are the answers. We're now going to take this concept and we're going to apply it. Please write this down for me. 2i times 3i times -4i. Evaluate this expression. Well, we're going to do it first using the patterns we know, and then we're going to come back and use the calculator. So I know 3 times 4, I'm going to forget about the negative, 3 times 4 is 12, and 12 times 2 is 24. So I'm going to write down a 24. And I prefer to go back and cross those out so I don't have any confusion. I also see that there's one negative, and I'm going to put it in front. And now how many i's do we have? We have a total of 3. Here we go. 1, 2, 3. What number in the sequence is it? Second. So I'm going to take this times -1i. A negative times a negative is a positive, and 24i would be our final answer. Grab your graphing calculator, please. Turn it on and press clear. We're going to take this exact same expression and we're going to use the calculator to confirm we have the correct answer. So start with the parentheses and then type in a 2. Now to get to the I, you're going to hit the blue key that says second and go down to the decimal key. You can see a blue I. So I have 2i, and then it's going to be parentheses 3i, and parenthesis, and then finally is a negative sign, which is below the 3, 4i. Press enter, and we can see that's the exact same answer we have. Okay? All right. Let's try another one. Please write down the square root of -9 times the square root of -24. So to do this, I know I cannot take the square root of a negative. It comes out and becomes an I. Again, comes out and becomes an I. The square root of 9 is 3, and we know the proper way is to write 3 in front. So that's the beginning of this as I evaluate this expression. Now I know the square root of 24 breaks into 4 times 6. So I have I times the square root of 4 times the square root of 6. The square root of 4 is 2. Bring down the I. Times the square root of 6. How do I multiply these two groups? We're going to multiply the like terms. 3 times 2 is 6. I have 2 i's times the square root of 6. What you have to memorize is that I squared is equal to negative 1. I squared is equal to negative 1. It's a second number, 1, 2. And the first number in our sequence is negative 1. So when I've evaluated this, my final answer simplified is negative 6 times the square root of 6. The very last learning objective is learning how to add, subtract, multiply, and divide complex numbers. So we're going to start with adding and subtracting, which is really simple. We can do it in our mind. Please write this down. 3 plus 2i plus 5 minus 7i. Okay, like terms. So here's the reals. So I have 3 plus 5. Can you simply do this in your head? Absolutely. I just want to show you how this is working. Plus 2 plus negative 7. 3 plus 5 is 8. And 2 plus negative 7 is a negative 5i. We can just visualize that. These two do not contain an I. They're the real portion of the complex number. 3 plus 5 is 8. These two contain an I, the imaginary portion. 2 plus a negative 7 is a negative 5 and I. Sometimes students want to put an I squared. Recall that if I just said what's 3x plus 7x, you would say 10x, not 10x squared. Same concept here. Okay, grab your calculator. We're going to show how it also works on a calculator. Parentheses 3 plus 2i plus parentheses 5 subtract 7i. Press enter, and there's our answer. 8 subtract 5i. Thumbs up or thumbs down? So now we're going to do subtracting. Let's type down 7 subtract 3i, subtract 4 plus 6i. Same concept. So could you just visually do this? Yeah, you could. 7 subtract 4. These are the real portions. 7 subtract 4 is 3. And negative 3 subtract 6. Negative 3 subtract 6 is a negative 9. We're just doing one of each of these, so let's still confirm you can know how to plug it in case that's your preferred way. Parentheses 7 subtract 3i. Subtract. Sometimes students get it wrong when they're plugging in, knowing when to use a negative and when to use the subtraction sign. And 4 plus 6i. And we can see we get the exact same answer. So at this level, we are introducing complex numbers, and we'll refer to that when we look at graphs, especially during this unit of quadratic functions. But just doing the operations. A lot of times when we get to multiplying and dividing, we do use a calculator just to speed up the process. I want you to only watch me do this one. Do not write this down. How many of you remember what it means to FOIL in math? You learned it in 8th and 9th grade, FOIL. What does F stand for? The first. 2 times 4 is 8. You're just watching. What does O stand for? Outside. 2 times negative 5 is negative 10. Attach the I. I stands for inside. 3 times 4 is 12. Attach the I. Last, positive 3 times negative 5 is a negative 15. Oh, there's 2 i's. What does 2 i's equal? I squared, which is negative 1. All right, so I have 8. I'm going to combine these two. Negative 10 and positive 12 is 2. And a negative times a negative is a positive 15. 8 and 15 is 23. Let's check to see if this math works. Grab a calculator, please. The first parenthesis, I know it's sloppy, when you look up at my screen, is 2 plus 3i. The second is 4 subtract 5i. Do we get the exact same answer? Yeah. Okay, and your last one is how do we simplify in fractional form? So please write this down. Let's do 2 plus 3i over 4 minus 5i. Just like we don't want to see a final answer with a radical on the bottom, we also don't want to see a final answer with an I, an imaginary number on the bottom. So to remove this I, but still keep the same value of this, we're going to multiply the top and bottom by the same value. And the value we multiply the top and bottom by is called the conjugate. Can you say conjugate? It means take this bottom, because we're going to do conjugate of the denominator. And we're going to write exactly what we see, but instead of writing subtraction for this problem, we're going to write addition. So I take whatever the denominator is, I rewrite it on top and bottom, and then I change the middle sign. And in doing so, you're going to see that our final answer will no longer have an I in the denominator. And that's our whole purpose of rewriting this in proper form. Okay, we're going to use the calculator to speed this up. On the top, let's do parentheses, 2 plus 3i times 4 plus 5i. And our final answer is, in the numerator, negative 7 plus 22i. Please multiply the two parentheses in the denominator. How many of you come up with an answer of 41? Now they want our final answer to be in standard form. Standard form, as we talked about, has an A and a B. The A is the real, the B is the imaginary. So I need to share this 41 with both portions of the numerator. My final answer is negative 7 over 41. That's the real portion of the complex number, plus 22 over 41. That's the imaginary.